Hi there.
Hi, welcome to a new episode of Chemistry Discovery Channel. As always, I'm Kayla Koschak.
And I'm Catherine Wong.
And today we're going to talk about different models, the different kinds of orbitals, and electron diagrams.
Wow, Kaylee, that sounds like a handful of fun today.
It sure does.
We'll be back after this commercial, but you better get your popcorn poppy now, because you're not going to want to leave later.
Do you have insect plant-eating problems?
Oh no, another insect. Oh.
Get caffeine, a natural pesticide that paralyzes and kills insects feeding on plants. It's a white, bitter, crystalline xanthine alkaloid that acts as a stimulant drug. Its name is 1,3,7-trimethylxanthine, and its chemical formula is C8H10N4O2.
Get your caffeine now.
Hi! We're going to start out with some basic understanding of atomic models.
The first basic model was developed by Bohr, and it shows the theory of how electrons circulate around a nucleus.
Bohr has 4 beliefs. Number 1 is there are certain paths which an electron can move in each path, and each path has a certain energy level.
Number 2 is each of these energy levels corresponds to a 3D pathway called an orbit, which the electrons can move around the nucleus.
Number 3, electrons could travel in one of these allowed orbits without losing any energy.
Number 4, the only way an electron can change its energy state was to jump from one level to the next.
Now, because of Heisenberg's uncertainty principle, which states it is impossible to determine the exact position or momentum of an electron at any given point in time, we know this model doesn't particularly work.
This led to the quantum atomic model. Erwin Schrödinger devised a mathematical equation to describe the energy and motion of an electron around a nucleus, and that electrons can have many different wave patterns called orbitals. Let's take a break before our next concept.
Breaking news! There has been a sudden snowfall happening in our city today. Stay in your houses, and if you don't know what snow is, here's an educated commercial for you. Snow. It's a particular form of water ice. When temperature is 32 degrees Fahrenheit or colder, water changes from its liquid form into ice. Temperature, air currents, and humidity all influence the size and shape. Stay safe, kids.
Welcome back. Let's take a look at the different orbitals. Now, remember, an orbital is a region of space where an electron can most likely be found around a nucleus.
The first orbital is the s orbital. Pretend that there is a small nucleus in the center of this circular balloon. The area around the nucleus, the outline of the shape of the balloon, is where the electrons can be found. The s orbital is a spherical shape and contains only 2 electrons.
The next orbital is the p orbital. It's a dumbbell shape, and the nucleus would be right in the middle where the balloons are conjoined. Now, this area, the shape of the balloon, is where the electrons would be found. Like the s orbital, the p orbital only holds 2 electrons.
There's also 3-dimensional shapes that the p orbital has. A horizontal 2px, a vertical shape 2py, and a diagonal shape 2pz. Each dimension holds a maximum of 2 electrons, which in total means p orbitals can hold up to 6 electrons.
The next orbital is the d orbital. Like the p orbital, it's also dumbbell shaped, so there's 2 dumbbells within the shape, and the nucleus would be located right in the center where all 4 balloons are conjoined. Now, the area around the shapes are where the electrons would be found, which each dumbbell shape holds up to 2 electrons. But the d orbital has 5 different dimensional shapes to it, which means it can hold up to 10 electrons in total.
Wow! The d orbital is pretty complex. The 5 different orbitals are dyz, dxz, dx squared y squared, and dz squared. As you can see, we'll be back after a message from our sponsors.
with the help of bananas and the potassium they contain, I was able to pull all of these accomplishments off. Eat your bananas, kids!
Welcome back. Let's take a look at energy level diagrams. When completing an energy level diagram, you have to consider first, the energy level or shell, second, the shape or type of orbital, and 3, the number of electrons in that orbital.
For example, 1s2. The 1 represents the energy level or shell. The S represents the type of orbital or the shape, and the 2 represents the number of electrons in the orbital.
Now, when completing these diagrams, you have to consider 3 important principles or rules. The Aufbau principle, the Pauli exclusion principle, and the Hund's rule. The Aufbau principle states that electrons will occupy the lowest available energy level.
The Pauli exclusion principle states that no 2 electrons have the same quantum numbers, so an orbital can hold 1 positive and 1 negative electron. It can never be the same charge of electron.
And last, but certainly not least, the Hund's rule states that electrons remain unpaired for as long as possible. So you have to fill up each orbital before beginning to pair the electrons.
Here's a chart to explain for all of those visual learners out there.
And so we'll look at 1s2, which has 2 electrons max. 1, 2. Now 2s2, 2p6 has 8 electrons max. 1, 2, 3, 4, 5, 6, 7, 8. And basically, all the s orbitals will always have 2 electrons max, as you can see down here, and the p orbitals will always have 6 electrons max, as you can see here. And for the d orbitals, they will always have 10 electrons max, here.
But be careful. There are 4 exceptions for this process: chromium, copper, silver, and gold. Hybridization occurs by overlapping of orbitals. There's 5 different hybrids: sp, sp2, sp3, sp3d, and sp3d2.
When completing diagrams for these exceptions, you have to transfer an electron to the next orbital available if there is a full orbital. So for example, copper. You will have to move an electron from 4s to the 3d, which makes the element more stable and more balanced.
So the end result would be 4s3d10. So there we have it. Thanks for watching. See you next time.
So today what we have here, my little scientists, is some ice, which I have concluded came from the freezing rain this morning. And if none of you guys are aware, freezing rain is the name given to rain that falls when surface temperatures are below freezing. So let's just check out that the temperature is below freezing on the surface. So, yep, that is below freezing right there. So if none of you guys are aware, the freezing rain is made of entirely just liquid droplets. So let's just take a second and listen to those droplets drop. And those raindrops become super cooled while passing through a sub-freezing layer of air many hundreds of feet above the surface, way into the deep sky. And then they freeze upon impact with any object they encounter. So, like the ground, the cars, the trees, the fence, the houses, and the window. And that concludes Fun Facts with Catherine today. And special guest was her PJs. Bye, guys.
And there we have it. And there you have it. Thanks for watching.
Thanks for watching.
Man, we're chemistry white. Be like, oh, okay guys, that's a wrap. And chemistry white. Let's get some H2O.
Beautiful. That's how the cookie crumbles.